Well, happy Tuesday. So at this point, you should have finished completing the review for final day 2, chapter 6.2 to 6.5 to the best of your ability. And this is where I'm going to answer your questions. So watch this carefully and check your work. Make sure you're doing this right. There'll be quite a few of these questions on the final. And yes, of course, you can use a calculator. You cannot use a phone, but you can use a calculator. All right, let's go through it. Determine whether the table represents a linear or an exponential function. So if it's linear, that would mean you're adding the same thing each time. If it's exponential, it would mean you're multiplying the same thing each time. So just check out what's happening. Here, I'm multiplying by 2, I'm multiplying by 2, I'm multiplying by 2. So that's going to be exponential because I'm multiplying by the same thing each time. So exponential because we're multiplying by the same number each time. And that, of course, is called your growth factor. And then it says write an equation. Well, the equation is going to look like this. Y equals a times b to the x. B is the number you're multiplying each time. In this case, it's 2. A is your initial amount. Your initial amount is at 0. So if there were a 0 here, this number here would have to be 3. And therefore, your answer is y equals 3 times 2 to the x. So we start at 3 and we go times 2 to get 6, times 2 to get 12, times 2 to get 24, and so on. All right, let's see. Does this table represent linear or exponential? Well, let's find out. So here I'm going down 9 or times 1/10. Here I'm going down 9. Oh yeah, we're going down, aren't we? So it is going to be linear because you're adding the same thing each time. So let's see, what is it that we're adding each time? Well, actually, we're subtracting in this case. We're adding a negative number. So it's going to be y equals mx plus b. So explain it. You have to write linear because we are adding, how much are we adding each time? Well, let's find out. So b is your initial amount. That's right here. So my initial amount is 1. So I'm starting at 1 because that's where x is 0. And then notice this though. I'm going down by 9, but so to speak, if this were Bob and his money, he's losing $9 every 3 days. Then he loses $9 in the next 3 days. Then he loses $9 in the next 3 days. So remember that your slope is the change in the y over the change in the x. So the y's are changing by -9, the x's are changing by 3. So slope is -9/3 x. In other words, y equals -3x plus 1. Bob has $1 and he's losing $3 a day because we're adding -3 each time. So if you're adding the same thing each time, it's linear. If you're multiplying the same thing each time, it's exponential. And I need to sneeze. Whee! Sorry about that. All right, let's graph this. So to graph this, we're going to make a table. And I'm going to make it over here in the margin, I guess. So plug in -2, plug in -1, plug in 1, plug in 2. And let's see what we get. So I'm going to start with the 2. So if I plug in 2, 2 squared is 4, times 4 is 16. If I plug in 1, 2 to the 1 is 2, times 4 is 8. If I plug in 0, 2 to the 0, don't forget 2 to the 0 is 1, times 4 is 4. If I plug in -1, 2 to the -1 is a half, 4 times a half is 2. And if I plug in -2, 2 to the -2 is a fourth, and 4 times a fourth is 1. And this shouldn't be too surprising. It starts at 4 because of that, and we're multiplying by 2 each time. You see that? So let's graph it. So 0, 4 is going to be here, 1, 8 is going to be here, 2, 16 is off of the graph, -1, 2, -2, 1. And so this graph is going to make a curve like this. It's an exponential growth curve. It's never going to go below the x-axis, and it's going to go up steeply forevermore. Number 4. So let's see. We start with 3,300 gas grills. The store expects grill sales to increase by 6% each year. About how many grills does a store expect to sell in 6 years? Okay. So we have our exponential growth equation. But very often, B is expressed as a percentage. A is still your initial amount, B is your growth factor, but B can often be written as 1 plus or minus a certain percent. So my equation then becomes y equals the initial amount times 1 plus or minus a certain percent to the power of t, which stands for time. So that's what the equation often looks like. It's the same equation, just that B takes on a slightly different form. And we use t for time usually. So in this case, I'm going to have 3,300 grills times 1 plus 0.06%. And how many years? So in 6 years, we'll put 6 there. And for that, you just need a calculator. So I'll put it in. 3,300 times 1.06. I'm adding the 1 and the 0.06 together to the 6th power. And the answer is 4,681. So about 4,681 grills. That's what they'd expect to sell. And obviously that number probably ought to be rounded to like 4,700-ish if you were ordering the grills, but there's our number. Number 5, identify the initial amount A, the rate of growth R as a percent, and evaluate for t equals 5. Okay, so the initial amount on this one is 1,200. The growth rate R is 20%, because this number here is 1 plus 0.20. Therefore, that is 20%. And in 5 years, it'll be worth, I'll come back to that. Here, my initial amount is 1.5, and this 0.95 is 1 minus 0.05. And therefore, this is a rate of negative 5%. You're losing 5% per year. Evaluating this should be fairly simple. 1,200 times 1.2 to the power of 5 will give you 2986. Make sure you know how to use all these buttons on your calculator, because you can use a calculator on the final, because you're going to need it. As long as you know how to enter things, you'll be fine. So this will be 1.16. Nearest tenth, it says, so I'm going to go with 1.2 on that, and this will be 0.0. Okay, a population of 100,000 decreases by 2% each year. Write an equation for this situation. Okay, so y equals 100,000 times 1 minus 0.02 to the power of t. If you want, you could also write it this way: 100,000 times 0.98 to the t. If the population is decreasing by 2%, that means that 98% of the population is staying each year. So obviously we'll start with 100,000. That one I can do in my head. Then if it loses 2%, well, it's going to go to 98,000. That one we can still do in our head. And now finding 2% of 98,000 is a bit of a chore, so forget that. So I'm going to kind of do this in my calculator. Times 0.98. And that's, of course, the first number, times 0.98 again. Oh, no, I have too many zeros. Hang on, I messed up. Let me try that again. 100,000 times 0.98. So there's my first year, times 0.98 again. So now we're at 9640 times 0.98 again. And every year it's just going to be 98% of what it was the previous year. So it's going to go down like that. If you don't like doing that, you could just enter it like this: 100,000 times 0.98 to the third, for example, would then give you that one. So if you want to do that, you can too. Okay, flip it over. A population of Bremerton. Oh, the population of Bremerton is that many people. It has been increasing. Okay, this is very similar. So y equals 111,000 times 1 plus 0.2 to the t. That's it. What will the population be in 10 years if this trend continues? Well, actually, it'd be nice if we wrote it this way. Some of you are starting to get used to this. So I'm going to call it P of X, the population of, actually P of T, the population as a function of time. So the population in 10 years will be 1.02 to the 10. And for that one, we just use a calculator. and it will be 135,000-ish. Round to nearest what? Nearest 1,000? Okay. So the population in 10 years will be about 135,000 people. And there you go. Pretty easy if you know how to use that formula. Write a function that represents the balance after 2 years. You're earning 8.4% annual interest compounded monthly. Oh, no, erase that, erase that, erase that, erase that. Oh, shoot. We didn't talk about compounded monthly this year. We only did compounded yearly. So we'll do yearly. I'll make sure I tell Mrs. G about that. Write a function that represents the balance after 2 years. Okay, so it's the same equation. So my balance after 2 years will be, my initial amount is 6,200, 1 plus 0.084 to the power of, oh, t. That's it. Doesn't even ask me a specific number. That's it. So you're done. So 6,200 times 1.084 to the t. And you can put a number in for t if we want to know 10 years or 8 years or whatever years, and that would be that. So there's that. All right, so here's some equations. So the principle here was this. If the bases are the same, then the exponents must be the same if the left and the right are equal. Since the left and the right are equal, and the bases are the same, that means the exponents must be the same. Therefore, all you can say is that x plus 1 must equal 5. Subtracting 1 from both sides, we get that x equals 4. You can check that very easily. Plug in 4 for x. 4 plus 1 is 5. So basically what this says is 3 to the 5th equals 3 to the 5th, which is obviously true. Here, I don't have equal bases, so I can't make that reasoning yet. But I could rewrite the 4. Let me zoom in on this. These numbers are really small. I can rewrite the 4 this way as 2 squared to the x equals 2 to the x minus 3. Because 4 and 2 squared are the same number. So now here I have the power of a power, so we're going to multiply those. And now I can say that 2x equals x minus 3. Adding x, subtracting x from both sides, I get that x equals negative 3. There you go. Question number 11. Same deal. I don't have a common base, but I can sure get one. I can make it 4. 16 is 4 squared. 64 is 4 cubed. This is why you really need to know the perfect squares and some of the simple cubes. You should just kind of memorize them. You should all know that 4 squared is 16. Yeah. So this is 4 to the 4x. And here, you're going to have to distribute. This is 4 to the 3x minus 9. Therefore, I can say that 4x equals 3x minus 9. Subtracting 3x from both sides, I get that x equals negative 9. Yep. Okay. Number 12. Well, what's my common base here? Well, what is it? Come on, what is it? That's right, it's 5. So 1/25 is 5 to the negative 2. And 125 is 5 to the 3rd. So now, distributing here, I get 5 to the negative 2x minus 4. And here I get 5 to the 6x. That means that negative 2x minus 4 equals 6x. I'm going to solve for x by adding 2x to both sides. And then dividing by 8. I'm going to get that x equals negative 1/2. That one was a little tricky. Good job if you got it. Number 13. Well, I hope you remember that a square root is actually an exponent of 1/2. So this is 7 to the 1/2. 49 is 7 squared. So here I get 7 to the 1/2 equals, distribute, 7 to the 2x plus 4. So now I have 1/2, which I'll write as 0.5 if you don't mind. This is going to be kind of a groby answer. And we'll take away 4 from both sides. Positive 1/2 minus 4 is negative 3.5. Dividing by 2, I get x equals negative 3.5 over 2. That's kind of a gross answer. Negative 1.75 or if you want as a fraction, negative 7/4. Sometimes the answers aren't very pretty. That happens. Okay, last one. The first thing we should do here is divide by 2 because we can. And we get 6 to the x minus 1 equals 36. I realize that 36 is really 6 squared. So x minus 1 equals 2. Adding 1 to both sides, I get x equals 3. That would be my final answer. Okay, I hope you guys did well on that one. Practice these questions. Redo them if you want. I have a blank copy, of course, posted here in Google Classroom. If you want to print out a brand new copy for yourself and redo it until you're sure you got it, that would be an awesome idea. Exam is next week. Okay, see you tomorrow.